Good morning, good afternoon, good evening, depending on where you are here today. My name is John Myers, and welcome to the RapidMiner plus Hadoop Turning Big Data into Action webinar hosted by Enterprise Management Associates. I want to tell you a little bit about our agenda today. We'll do some introductions of the folks that will be here on the phone. We'll talk a little bit about the state of the big data and advanced analytics markets. And then we'll also talk about the benefits for advanced analytics for Enterprise Hadoop. And then as we finish up, we'll be doing some questions from the audience and answering those with our panelists today. My name is John Myers. I'm a research director from Enterprise Management Associates. I'll be your host and providing a bit of background on the industry of big data based on end user research that's done by Enterprise Management Associates. Today I am joined by Ingo Mirzwa, who is the CEO of RapidMiner. And then we're also joined by Zoltan Prikopchek, who is formerly the CEO of Radoop and now the newly minted Vice President of Big Data here at RapidMiner. So the logistics for today's webinar, if folks have questions, they can put it in the question and answer panel located in the lower right-hand corner of the screen, and we'll address some of those questions throughout. And a recording of this event will be archived at both RapidMiner.com and at EnterpriseManagement.com for future viewing. So to start our webinar today, I'm going to give you a bit of information about the state of the marketplace for advanced analytics and big data. Enterprise Management Associates over the last couple of years has done an end user research study where we go out and ask end users of big data technologies what they're doing with their projects. And we don't start this from a technological perspective, but we do, in fact, ask people what are the business challenges that they're trying to meet associated with these events. So, you know, we found that big data platforms have multiple uses. We've seen them in both operational, analytical, and exploratory environments. We found that over 50% of the respondents of our survey are using big data for analytical purposes, and almost 3 out of 10 of them are using them for exploratory use cases, where they're taking their fingers, putting it in the data, and trying to determine how they can use it to better move their businesses. What is driving this this goal towards big data? We're finding that the line of business stakeholder is definitely one of the reasons that people are trying to move forward with big data analytics. We found that a majority of end users are using big data to try to find information about the behavior of their customers or to be able to implement greater levels of advanced analytics associated with their big data environments. Some of the project challenges that we found that are going on are things that lead very well into the world of advanced analytics, predictive classification, things of that nature. The #1 project challenge that we found with our big data research study was in terms of risk management. You know, how are people looking at fraud analytics or liquidity risk management associated with financial services? Also, asset optimization was another one of our key project goals, where people are looking at optimization in terms of staff scheduling or logistical asset planning. And then campaign optimization, cross-sell, upsell types of classifications and bucketing so that organizations can understand how to increase their top-line revenue or lower their costs associated with attempting to do customer churn and things of that nature. So all of these business challenges are the types of things that are driving big data, not necessarily merely the technological capabilities, but what are the key business objectives as people are trying to use these particular technologies. When we look at the analytics that people are trying to use, Enterprise Management Associates has a concept called the analytical pyramid, where we take a look at things that go all the way from simple analytics or simple aggregation, being able to say who are my top 10 customers, who are my top 10 customers by region, all the way up into clustering, segmentation, and predictive analytics, or what we might refer to as advanced analytics. And we found that in those areas that predictive and clustering have significant components of our end user base that are looking at how are they going to take big data and make it work. It's not simply that they want to count up the number of events that they may have available to them from their web services. It's not that they want to take a look at how many tweets are being done by region. They're looking at taking that particular information and using it in much higher levels. So to do predictions, to do clustering and classifications, things of that nature to say, how do we move forward with this information, not just how do we do some of the things that we've been able to do before. In terms of big data analytical platforms, we found that instead of organizations picking a technology and trying to decide what they can do based on that, they're setting business goals at the center in terms of economics, data loads, data structures, whether it be structured data or multi-structured data, speed of response or complex workloads. These are all concepts that all go together that drive the selection of particular platforms for big data implementations. When we take a look at this, we've been able to project that for 2014, the most average or straw man type of big data environment is going to consist of anywhere between 6 and 120 terabytes worth of disk space. This is up considerably from where we projected it just last year. And this is a size that becomes very difficult to maintain if you have a high economic cost associated with those big data components. But it generally shows you that this type of big data management size is not just something that's going to be something that will allow you to do it easily on a high cost environment, but it's something where you need to make decisions about how are you putting data in the right places to match your budgetary constraints. In terms of how people are allocating their platforms associated with this, we have invented a concept called the hybrid data ecosystem, and we found that almost 65% of our respondents are using between 2 and 3 different platforms associated with their big data efforts, which means that there's no one platform that allows everything to be done all in one place. People are sharing this information across multiple platforms, and when they bring it all together, it looks a lot like this in terms of what we refer to as the hybrid data ecosystem. And these platforms include structured and multi-structured environments. Some of the key components are, Hadoop and NoSQL. All these things come together to be able to maintain those requirements that we have there at the center of the hybrid data ecosystem. Now, the people who really bring this information all together are the data consumers associated with a particular environment. When we asked our end users who are the strongest users of their big data environments, or who are the end big data consumers, we found that business analysts and line of business executives represented almost 50% of those people that were going to be using the information coming out of these big data environments. While the data scientist was, in fact, one of the top users of this, they were down in 4th or 5th place based on the information that we had. But seeing this information says that these business users, people who may not be as skilled in terms of how to build out predictive models or how to interact with systems at a command line interface, these are the types of folks that are generally using these systems. Now, to really enforce this, our respondents told us that almost 50% of all big data projects were receiving some type of non-IT funding. So these business users are not only using the systems, but they're helping to pay for the systems so that they can get up and running with the fastest time to implementation that they can get. So there's definitely a play in terms of these big data environments that's associated with individuals that are not associated directly with technical backgrounds or comfort levels with, as I like to call it, hand-rolling of advanced analytics and things of this nature. These business analysts are looking at ways to get at this information in a way that's appealing and works for their group. In terms of how do people get up and enable these users, we ask people about how are they going to bridge the skills gap in their big data environments. And we found that between training certification programs being answers number 1 and number 2, we found that they're going to try to exploit the features and functions of products so that they're not trying to do things at the command line and put everything together by hand. They're trying to utilize best practices and lessons learned that have been productized and integrated into existing product structures to really help them do this. So instead of trying to go out and acquire the relatively expensive and scarce resource that is the data scientist, these organizations are, as we've shown, trying to train up and grow their internal staff members and lower that learning curve so that those staff members can get up to speed much faster using different components of products that are available in the marketplace today. At this point, I'm going to hand it over to Inigo, and he's going to talk about the benefits of advanced analytics for Hadoop.
Thank you very much. Yeah, absolutely. Advanced analytics, as you're all aware of, are really covering different topics, including predictive analytics, text analytics, but also simulation and optimization. And we would really like to touch those different aspects, as RapidMiner always has been doing, but now in the Hadoop context. So let's start maybe by thinking what really Hadoop is about and this whole big data space is about. We all are hearing big data, yeah, well, left and right, but I think the major message here really is that Hadoop is the core technology of big data. So it is first of all a description of data infrastructures and a parallelized paradigm to use multiple computers, multiple nodes to make faster computations. And that really can be used on commodity hardware to speed up those calculations and get more efficient to your data. So this was a huge change introduced a couple of years ago, and by now actually basically every company in this or every organization in this world really has already a project or plan in place to use Hadoop at one point in time. Actually, about a third of all us participants already have Hadoop already in place and deployed. So the big question really now is if Hadoop is everywhere, how can we really bring advanced analytics towards this data structure, and how can we really use advanced analytics on top of those data structures and make use of the computational power? Before we can answer this question, the first thing we should really understand about Hadoop, what makes this huge difference. Until a couple of years ago, the only option organizations had to work on larger amounts of data was really to scale up their database systems, their data warehouses, which, well, sort of works up to a certain amount or of data which you would like to store. But then all of a sudden, thanks to the data explosion we have seen in the last couple of years, every single event is logged, web events are logged, every transaction with customers are stored somewhere. This is really exploding so fast that actually this whole model with a centralized data warehouse storing all this information does no longer work, at least not in a cost-effective way. So let's assume for Hadoop, you set up multiple nodes based on commodity hardware, and every node is really coming in, let's say, at a price of $1,000 per year. So it is this assumption. Really, you could think about, okay, the investment is, let's say, $1,000 for a terabyte for a year, and that allows you to really scale beyond the limits we have seen so far. And that makes a huge difference, which is really now allowing you to store basically everything. I mentioned the web logs before, but think about a telecommunication provider. Think about just storing the information, who is talking, how long, with which other person. This type of information, which needs storage anyway, this is the typical situation where Hadoop really can play its strength. The second point I already mentioned before is that Hadoop is a distributed computation environment. And that means for us as a predictive analytics vendor that we can not only connect to this distributed environment and get the data out of there, which is great, but actually it could be even greater if you could just push the algorithms and push the computation on this cluster so it's well calculated there in a distributed fashion. Another advantage, which is very nice, especially for everybody who's used to work with the more traditional data warehouse approaches since some time. Usually in the Hadoop world, you don't really need to predefine your schema, and then you have to stick a database schema, how the data relates to each other, and then you need to stick with this for the rest of the lifetime of the data warehouse. In case of Hadoop, you're much more flexible and can adapt this over the lifetime of the data storage, as long as the tools connected to this data are as flexible. So that all sounds great. Scaling up with commodity hardware, pushing computations maybe on the Hadoop cluster and making use of the computational power. So, and many companies are embracing this already, which we have seen before. So the big question really is, why not more? And why is not every company doing this? Well, I think it starts with the idea or with the finding that data alone is actually not of much value. So it's great that we can store and retrieve data now more effectively or efficiently, but on the other hand, we really have to bring those algorithms to the data and bring algorithms and data together to make actually really value and use out of the data. So it's the underlying patterns, the hidden correlations, which you need to find to really understand what's going on and to turn data into knowledge which you can act on. But that's really part of the problem with Hadoop. Hadoop is still a very early technology, or a technology in its early stages. It's a great technology developed over multiple years, but at the same time, it's consisting of multiple elements which are, well, relatively complex in its setup and organization. So, and although it was improved a lot over the last couple of years, still setting up a Hadoop cluster and working with this cluster on an everyday base is relatively complex, and usually you need programming skills to really work with the Hadoop cluster. And that's something which obviously not every person who actually would like to make use out of the data, that's the skills that those people not necessarily have. So, and that's true in general. So if you need those statistical skills and those programming skills, and then you also have to understand the way how to store the data in the best way. If you have this very specialized skill set, this might lead to a skill gap where your organization doesn't have enough people in place to overcome those hurdles. The same is actually true when it comes to integration, because even after you found those patterns and correlations, and even after you really worked on this large amount of raw data to find those things, the big question is, what are you doing then? We always say at RapidMiner, there's no point in just predicting something. You need to predict, and then you need to act on that. So you're making millions of small predictions, and then you trigger business actions as a part of your business process millions of times. And for that, in order to be able to do that, you really need to integrate those predictions into the rest of your IT infrastructure. But something like that is also missing for Hadoop. And finally, actually, usually the problem definition starts from the business side, but most line of business managers are really sort of disconnected to the underlying technologies, especially if they require high programming or statistical skills. On the other hand, there are data analytics groups, IT professionals who could solve that, but sometimes there's some gap towards the business side, and that's a problem we already know from so many other projects from the past, especially in the BI field. But the technologies which require programming and statistics, this is even harder to overcome. So those are the typical challenges of Hadoop, and we need to find something to overcome them.
So Ingo, this is John Myers again. Some of the research that we've done over at EMA has shown that extended time to implementation is one of the issues associated with a Hadoop platform, because to date, as you pointed out, it's a relatively new technology that's based a lot on a development environment developed by developers, if you will, as opposed to coming from more of a business orientation, as you pointed out. Zoltan, tell some of the things that you feel are important in, trying to solve some of these challenges associated with I wouldn't call them the deficiencies of Hadoop, I call them the kind of the growing pains of Hadoop. What have you found that helps to solve some of these issues?
Yes, certainly. I agree with both of you that this kind of complex technologies and the pain involved with solving these hurdles is one of the big barriers of the adoption of Hadoop itself. So certainly graphical user interfaces or some other abstractions which allow you to work on a higher level without understanding all the complex technologies behind is certainly very valuable for the success of these projects.
Okay, and then you mentioned visualizations. We found that our end users felt that a lack of a visualization layer, directly in Hadoop and with some of their tool sets, or I guess sub-projects would probably be a better way to describe it, was one of the limitations that they found. Are you finding that with some of the folks that you're dealing with as well, that simply going command line is kind of a barrier to entry to some of the business users that we're talking about?
Yes, absolutely. I mean, just a simple example is that most of these Hadoop clusters are based on Linux, and many business users are just not really comfortable with using Linux and doing SSH and things like that. So just the ability to access these data sets easily and visualize them is a big win for them.
If I could add to this, I think really that is exactly what is missing for Hadoop right now. It is really this easy-to-use first level, which usually starts with visualization in the first place, to give value immediately to business professionals. That if you don't have something like that, it just stays an abstract technology you're really disconnected from. If you want to look into the data, the typical workflow is you start asking questions about the past. What happened last year? How many calls did we store? How many people have visited our website? How long did they stay? Whatever the typical questions about the past are, then you start realizing, oh, that's great. I have this data now available. Maybe you can look a little bit more in real time. So what's happening right now? And then the next question is, okay, what's going to happen in the next time? And that's where predictive kicks in. But the way how we are usually presenting those models and results and predictions is through visualization, because that's exactly the language people are talking in. It's not really in MapReduce jobs. It's not really in Hive SQL statements. There's no point actually in bringing people to this level. You need to start with the visualization. You need to show the insights, the intelligence part basically right away. And that was a clear lack of Hadoop technology so far. And Radoop is using basically the visualizations from RapidMiner now to be able to create them actually in a few single clicks, and then you can deliver them to the business user who can drive or derive direct use out of that.
Well, excellent. And I think that brings us to one of the big pieces that we're talking about today is the RapidMiner acquisition of Radoop.
Yes, so RapidMiner acquired Radoop. We have been working since 2011, very, very actively working together since then. And one of the reasons, or maybe one of the major reasons why we still believe Radoop is such an exciting technology is because it does exactly what I mentioned before, which is really not just taking the data out of Hadoop and then doing some computations in memory or in some database or at some different places. It brings the algorithms, it brings the visualizations to the Hadoop cluster. Everything is calculated there, and then you can make use of the computational power. And that's the huge difference between Radoop and so many other technologies. But now think about this and mix this technology advantage with the ease of use of RapidMiner, where there is no coding, where you can sit there and draw basically a data workflow in a complete visual environment where you just combine building blocks. So it's super easy to use, and it makes use of the computational power of Hadoop clusters in a very easy way. And that's just something the market was asking for, looking for, and now it's existing. Zoltan, what's your point of view on that?
Yeah, so what we have been doing in the past 3 years is to remove these complexities and remove these barriers to access and analyze data on Hadoop. So we have worked with this RapidMiner interface that is very easy to use and created new building blocks that you can use to analyze your large data sets sitting in Hadoop. So we essentially remove the requirement for a special skill set. So analysts using this tool are not required to understand these complex technologies of Hadoop, MapReduce, Hive, Pig. If they are capable and if they have the programming experience, they can do that. So we have ways to address these technologies. But we allow these different people from different skill set to collaborate and create these data processing workflows for big data.
So that is a perfect fit, actually, to the key value proposition of RapidMiner in the first place. So everything we do at RapidMiner really follows three very simple ideas. So the first one is simplicity. We absolutely believe that for all those standard tasks for data integration, data transformation, but also data modeling, also predictive models, there should not be the use for reinventing the wheel all the time over and over again and then implement those new algorithms. It should be doable in a graphical way. It should be doable with a couple of single clicks. It should be much simpler than by learning a programming language for a long time. As also pointed out, if you have this capability, you should be part of this collaborative team, which is the second basic idea and basic key value proposition of RapidMiner, that we are supporting a team of people, the business analyst who's in the driver's seat and can build those graphical workflows very, very simple. The business user who delivers the problem type and the problem description and understands if the solution is good enough. The IT professionals who usually own the data and should contribute the data into this team as well. And of course we support data scientists. They can develop own algorithms in whatever language they prefer, could be R or MATLAB or Python, and those algorithms are then integrated into the overall workflow. So simplicity is one, collaboration is the second, and predict to act, that is really the thing which is driving us most. In general, we absolutely believe, and I mentioned this before, that it's not just about creating predictions, it's also about the actions you can trigger through those predictions. Actually, you could call them prediction-based actions or short predictions, and that's the difference between prediction and prediction. Prediction really is about what's the weather prediction for tomorrow, and your answer would be, I'm bringing my umbrella. It's not important that it's going to rain. It's important, what is your best option then? Are you staying at home? Are you coming to the office but you bring your umbrella? So what is your best option for every single case? And that is what prediction is about. Since many people ask, how good is it working and how much does it really help? We did a little bit of research on this topic and analyzed typical project sizes and compared how much effort is going into creating this in a more, or solving a predictive analytics program in a more traditional way, including everything from data integration, data transformation, building the models, testing the models, optimizing parameters, finding out what are the most important influence factors, and also up to deployment, visualization, and also maintenance of a model over the course of 1 year. So if you do this with a more traditional scripting-based approach, well, it really takes you a complete year to do this for certain projects. If you do this with something like RapidMiner plus Hadoop, they really get rid of writing all those MapReduce jobs. You can really focus on just creating the overall workflow, which is also much easier to communicate about. If you do this with that, you will find that there's a speed up of about 40 to 50, a factor 40 to 50 compared to more traditional scripting-based approaches.
So it's oftentimes a good thing to take a look at some sample use cases and some customers that are associated with particular solutions. Zoltan, do you want to talk to some of the groups that we have here on the screen right now?
Yes, absolutely. So we have seen lots of interest from various industries for our products. And one of them has been the telecommunications. And they've been using Hadoop itself and RapidMiner to optimize marketing campaigns and try to avoid churning customers. So really what benefits big data brings to them is that they can dig deeper into user behavior. They can integrate multiple data sources like calling habits, like Ingo mentioned before, all the online activity that a particular user has. And they can better understand their customers' needs and preferences, so they are able to interact with them more properly. So that also resonates with this predict to act of RapidMiner, that predictive analytics that can help you with defining your best action with that customer. So really big data is mostly about the customers. Of course, there are many different use cases in many different industries, but understanding the customers on a more granular level is very interesting in various areas like banking or for internet companies, for media companies, or especially online advertising. That's one of the most important analytics aspects. So we have seen also a lot of adoption in the internet space. So some of these companies have been using this for product research, so understanding how their users are engaging with their products, trying to optimize features and functionalities, doing A/B testing and things like that to find out which feature is helpful for a certain group of users, and improve the product and improve their understanding of the different segments and their needs. So I believe currently this is mostly about the customers and understanding the customers in deeper detail.
Okay. And Zoltan, are a lot of these customers coming to you simply from a technological perspective, or do they have economic drivers that are bringing you in their direction as well? You know, the EMA research has shown that these big data environments are, they're not necessarily the petabyte version that we often hear talked about from some of the kind of the poster children for big data, but they're definitely not something that you can hide underneath your desk with desktop type of hardware. What are some of the economic drivers that people are bringing?
Yeah, so some of these customers are kind of making the switch from legacy data warehouse technologies because they found those technologies not scalable enough and also not cost effective enough. So of course Hadoop is highly scalable to multiple petabytes, and that is simply not available with other technologies. So that's one of the drivers from the technology point of view, but also, of course, from the economic point of view. Also, there are other companies who are experiencing huge growth, like these internet companies of Prezi, Ustream. They are collecting tens of millions of users, and they just really cannot plan for what amount of data they will have in a month or two. They need to have a highly scalable system where they can just put new nodes into the cluster, new capacity into their infrastructure, and they are able to handle the data load and able to handle the analytics challenges that they are facing. So that's a big difference, especially in this internet space, that these companies need to be prepared for high growth.
Sure, and that's also exactly the reason why this acquisition makes so much sense. And it is really the combination of the technology, but also a very interesting economic or offer from an economic perspective. So Radoop as a key technology is really one of the first, actually the first, which brings predictive analytics, advanced analytics technologies into Hadoop clusters, let the computation, or performs the computation there without, writing a single line of code. So that's a key technology which is fitting perfectly into the RapidMiner paradigm. It's already fully integrated with RapidMiner, and in addition to that, I know this team around Zoltan at Radoop for so many years now. It's a highly experienced expert team for everything around Hadoop. And so it's also bringing a lot of engineering expertise into RapidMiner. Another aspect on this acquisition is the growth of the market. There are some experts out there who predict that the Hadoop market is currently still growing up to 50% per year for the next couple of years. So it doesn't matter if it's now 10%, 30%, 50%. It's definitely one of the fastest growing markets out there. And well, this really enables RapidMiner to participate in this high growth market as well. One thing I personally find very intriguing is that Radoop, as RapidMiner, has been designed from day one with the enterprise in mind. This has to do with the collaborative aspect. This has to do with making sure that the maintenance or the cost for maintenance are not too high. The necessary skills are not too high. That it's easy to understand. The results are well presented. Visualizations, web-based or in the desktop client, are all available with very few clicks. The time to result is very short, because we all know if you have to start a project for something, you're not 100% sure if this predictive model is going to work or not, and then you have to wait 6 months or longer until you get finally the results. That was okay 15 years ago, but it's no longer okay as of today. And Radoop as a technology really allows to bring Hadoop into this new paradigm, where well, you could call it a self-service predictive analytics paradigm, where business users, business analysts can create those solutions on their own very, very fast. So Zoltan, maybe you would like to jump into some of the technical aspects of Radoop and explain a bit what is supported.
So a few months ago, we have just released Radoop 2.0 that includes more than 50 operators for Hadoop. Operators are the basic building blocks in RapidMiner, and we have more than 50 re-implemented to run directly on the Hadoop cluster and use all the resources of the distributed infrastructure. Radoop also supports the latest Hadoop distributions. So Hadoop 2.0 and the so-called Yarn resource management layer is a huge breakthrough in Hadoop technology and allows multiple workloads on the same cluster, and it's a big thing for doing advanced analytics on Hadoop. So we also support it, and regarding the different distributions for Hadoop, Cloudera and Hortonworks and DataStax are strong partners of ours, so our products work seamlessly with those distributions, and we are even a Cloudera certified technology. And we integrate with various Hadoop ecosystem projects, how they are called, to accomplish these advanced analytics features inside RapidMiner. So if you are familiar with Hadoop, we are integrating with various technologies, including MapReduce, Hive, Impala, in case of Cloudera, Mahout and Pig, to always address your advanced analytics problem with the right tool in the Hadoop ecosystem. Otherwise, you would need to be an expert in all these tools to accomplish the same. So we are kind of translating these graphical workflows into the proper Hadoop technology and execute on the Hadoop cluster.
So in summary, we've talked a bit about how big data and advanced analytics projects are growing in their scope from the marketplace. This just isn't one particular perspective. This is coming from both the analyst community, the end users, and the vendors that we've seen in the marketplace. But with that in mind, big data projects on simply Hadoop are a bit challenging. Coming from an almost exclusively command line interface background and a little bit of hand rolling, there are needs that the average business user or line of business executive, those tools that they need so they can become successful when they attempt to do projects with Hadoop. And that's where RapidMiner and Radoop really come together. They help to eliminate some of the challenges or some of the noted issues from our research of what Hadoop needs to be used to enable what's going on. But it also puts together predictive insight and action associated with big data, not just a model that you have available in a script somewhere or a result set as well. So as we move on from that, we're going to start going into some of the questions and answers that we've gotten from the registrants for the webinar today. One of the first questions that were asked, and it's always one that I like to talk about, is, and Ingo, I think maybe you can answer this one, is what kind of data can you integrate with, whether it be structured or multi-structured, text-based, what are some of the different data sources that you can bring to bear with the RapidMiner solution?
We support a lot of different structured formats, and you can name whatever the data source now is. If it's a relational database, if it's an analytical database, if it's CSV, Excel, Access, doesn't really matter. There is an operator for that in RapidMiner. So in the last, well, 12, 18 months, we never had a case where we have been finding a new structured data source which is not supported already. So that's the easy part, and structured data in general is more easy. Let's move forward to let's say, semi-structured data. For example, graph information, information coming from NoSQL databases or just XML files. In those cases, we have connectors to those data sources as well. Let's say in case of an XML file, it's just reading a file. But then we also offer operators which can parse the information out of the semi-structured data and transform this data into a more structured format. In this XML example, this would be just a collection of XPath expressions which can be used to say, okay, this is now defining a column, and this is the value of this column, and by this you can basically transform an XML document into a structured table format. Let's move another step. Let's go into the world of text mining and text analytics. So for all kinds of data sources coming from databases, also from files, we can read text files, text documents. But in addition to that, we also have text sources for RSS feeds, forum software, from APIs like from Facebook, Twitter, Google. So there are operators for all those data sources, so you can feed in this information, for example, from social media. And then there are operators which transform text documents again into a structured format. For example, going through steps like tokenization, filtering, stemming, doing some linguistic approaches actually. But at the end of the day, usually we are following our statistical roots and transforming those words or tokens we created by things like term frequencies or TF-IDF into, again, a more structured format. So, but we're not stopping at text when it comes to unstructured. We also support image mining, so loading image data in 2D and even 3D and extract describing features from those images. We can connect to audio sources, audio signals, and you would be surprised that there are actually a lot of applications, especially in the manufacturing industry, where you have sensor data and mix audio signals into that to, for example, improve on predictive maintenance. The same, by the way, is also true for image data. So there are now more and more applications where you need actually to combine those structured information and the unstructured data you have and bring those things together and build the predictive model on top of that. Yeah, so that's what is supported. There are hundreds of operators for data integration and then data transformation in RapidMiner. And the old saying still is true. You spend most of your time actually on this part, not on the actual modeling, because after we brought this into a more structured format, the modeling is actually pretty easy.
No, I agree. You know, when you're going through a predictive modeling exercise, I don't think people put enough emphasis on the concepts of data preparation and data lineage associated with what you're trying to put into the model. So those are all great components that work there. Zoltan, I think this question comes for you. How will a newcomer to Hadoop benefit from the Radoop offering and product?
Well, there's a very steep learning curve for Hadoop and all those related technologies. So someone being a newcomer to Hadoop would certainly need to spend weeks and months with understanding the key concepts and the key technologies and learn how to do analytics with Hadoop. And with RapidMiner and Radoop, they can really get access to those data sets and be productive from day one and accomplish results in a few days instead of months of learning and trying and failing with different programming exercises. So it's really shortening the time frame and speeding up of what they can accomplish with the same effort.
So it kind of in short, not only do you get the economic value of a Hadoop cluster, but you also will get a time to implementation speed that you would get with a structured product as well, correct?
Yeah, absolutely. Yeah, of course there is this economic impact of Hadoop itself, but once the company has decided to go for Hadoop, then still that's only the first step. So there's no value in having a Hadoop cluster and it's just sitting there and no one can access it and do analytics on top of that. So the next step is certainly to empower the people in the organization to get value out of those data sets.
Excellent. Ingo, I think this next one will go best for you. What type of visualization capabilities does RapidMiner have associated with their predictive modeling approach?
Well, that's an area we're actually pretty proud of. We have more than 30 different chart types alone for data, and there's probably a couple of dozen more for different types of models. So let's start with the data. Of course, there are the more typical visualization types like scatter plots or scatter matrices. There are things like bubble charts or parallel coordinates where you basically draw the line of a table, the row of the table as a line in a chart, which is really working well up to 60, 80, 100 columns or dimensions. There are some chart types which are actually not available anywhere else. Our deviation plot is a variant of this parallel visualization, which is usually very, very useful to find those influence factors and those columns where two different classes of data differ most. So there's obviously everything for time series prediction and series plotting. There are self-organizing maps. And then there's everything more traditional, everybody knows, like pie charts, bar charts, and those kind of things. So this is about the data. And basically all of those visualizations are available in the desktop client in a more interactive way. So you can really change basically every setting you could imagine of those charts. But then you can also use RapidMiner processes to create them with one of our extensions, the reporting extension. So you can, for example, create a loop over different data sets or create a loop over the columns of a data set and create all those charts automatically, create a PDF document and send it out via email, just as an example. So that's good because in a process-based layout, you can do things like that, which is basically not possible if you go with a pure BI visual approach where you really have to define everything as a user and can't make use of things like loop or other control structures for processes. In the web-based environments, basically all those charts are also supported, and that is something I always think of is this huge difference to, to be honest, more to traditional BI solutions. The difference is that every visualization you can see in our web interface of RapidMiner server is actually created with a process. And that means if you interact now with those charts and visualizations and click somewhere, this can actually trigger the execution of another process. And by that, you can trigger basically every action which is possible within a RapidMiner process, including writing data back to databases, sending out emails, invoking web services. And with all those things, you can actually trigger other business actions. And that makes those charts really actionable and not just interactive, if that makes sense. And then there are obviously visualizations for all types of models, for neural networks, decision trees, naive Bayes models, so you can see the distribution and all this kind of things, which are basically on top of the pure data visualization.
Excellent. Now, we've talked a bit about today how RapidMiner and Radoop have been partners for quite some time. I've seen different organizations describe partner as being anything from the exchange of logos on slides to standing nicely next to each other at a trade show. Can you guys give me a little bit of information about what type of partnership have you had over the years, and what type of integration do you have between the products at this point in time?
Well, let me start on the partnership, and maybe Zoltan can comment on the integration. So the partnership, it was what you would call an OEM partnership. So Radoop was an extension to the RapidMiner platform, and as such, this partnership was working like this extension was marketed together as in a bundle with RapidMiner, the actual platform itself. So it was a new product consisting of both elements, the Radoop extension to the RapidMiner platform and the platform itself. So that's how we marketed this in the past, and obviously also for us as a company it's now much easier. But the biggest advantage is for the client because they really get now both elements of this platform and extension from the same organization, which makes it much simpler than the need to deal with two organizations. So that's on the partnership. Zoltan, maybe you would like to comment on the integration?
Yes, of course. So we have been working on the technology side to integrate these two products as well as possible. Yeah, it was actually a close collaboration. So sometimes we had discussions with the developers and had even kind of hackathons to try to integrate our products better. So there was a great collaboration, and I expect to continue that and be even stronger than that. So Radoop itself is already deeply integrated. So you can use RapidMiner Studio to create and maintain these big data workflows. You can also use the server, RapidMiner server with Radoop to put these processes into production and schedule them for regular execution or generate charts and plots on the web interface from those results. So it's very tightly integrated already. Yeah, Ingo has already mentioned some of the benefits of this tight integration, and also that it's much different from being just a Hadoop connector. It's really running all the computations on Hadoop, and it brings a kind of a new execution engine for RapidMiner, if you wish.
And without giving away some of the secrets of the roadmap, Zoltan, where do you see kind of the future for the two technology bases as we move forward with the combined offering?
So, of course, Radoop having like around 50, 60 operators at the moment, we are adding more and more advanced analytics features in the near future. So including more machine learning algorithms for classification, regression, doing outlier search, recommendations, and things like that. These are certainly coming in the next releases. And we are also planning lots of new features regarding processing text on Hadoop, and also looking into some stream processing systems and how to enable more real-time use cases for analytics. I believe that the integration with the server is already a very good step for that, as it allows to apply and score these predictive models on new data coming in. But we have some more plans on how we can integrate these new technologies.
Okay. Ingo, did you have any additional comments on the future combined solution?
What is really important for us is to continue on this path to really breaking down the silos. I mean, really, you can now create a predictive model in Hadoop with Radoop, and from the RapidMiner perspective, this just you define a context where everything which is living in this context is executed on the Hadoop cluster. Then you create a model, and the model is usually much smaller than the data itself, in most of the cases at least. Then you can feed this model into in-memory, let's say, and do some changes on this model in your in-memory engine. And then you will continue, basically, or you can continue then, and feed this model into your database or in the traditional data warehouse and apply this model for scoring on the complete data warehouse. So instead of having to deal with 3 different environments, you can build this one overall process which is really governing this whole approach. And that's something which is already working now. But now the next level, and Zoltan touched on this already, is really now how can we add even something like a Storm as a real-time and stream technology into this mix, and how does that really work out? And we're currently really figuring out how to support this best, so that it still makes no difference at all for the user of RapidMiner, that you really can stay in the same visual environment and mix then real-time on Storm with distributed computation in a batch fashion on Hadoop, and let's say scoring on the data warehouse and some computation in memory. And really, it doesn't any longer, doesn't matter any longer, because it really, for the user, it just feels like I'm one unified environment. And that's really the vision for the product.
Well, excellent. I think we've come to the end of the time that we have here today. I want to thank Ingo Mirza and Zoltan Prikopchek for joining me, John Myers of Enterprise Management Associates, to talk about the RapidMiner and Radoop integration. If you'd like to get more information about RapidMiner and Radoop, you can find infographics, press releases, videos on the RapidMiner website at rapidminer.com. You can also download version 6 of RapidMiner at rapidminer.com. Again, a recording of this particular event will be available at both at rapidminer.com and at enterprisemanagementassociates.com. So at this point, we've come to an end. Ingo, Zoltan, thank you so very much for joining me today.
Thanks, John. Thanks for the time, also to the audience.
Yeah, thank you, John.
All right. And thank you for everyone who took time out of their day to join us for this webinar. Have yourself a great day and enjoy your afternoon.